Hello everyone. In this video tutorial, we will learn how ChatGPT was trained. But before we go ahead towards it, let me clear a few things. So you all have heard about ChatGPT and you have used it as well. So ChatGPT is just an application like any other mobile or web application. So the ChatGPT internally makes a call to OpenAI API. So how ChatGPT works is that ChatGPT basically or ChatGPT application internally makes a call to OpenAI API, and OpenAI API internally uses GPT 3.5 and GPT 4 models to generate a response. So when the user asks a question about anything like generate a summary of the book Alchemist. So if I ask this question to my chat GPT, generate a summary of the book Alchemist. So when the user asks a question, the chat GPT application internally makes a call to OpenAI API, which internally uses GPT 3.5 and GPT-4 model to generate a response. So if you have a ChatGPT premium subscription, you can use GPT-4 model as well. But if you don't have the subscription, you will be able to use GPT 3.5 model to generate the response. So in the similar way, if you want to create a book summary generator application where the user write the name of the book and the application will generate the summary of that book. So the book summary generator is an application similar to ChatGPT. In the book summary generator application, the user will write the name of the book, and we will pass the complete input prompt which we have written in the backend, like write me a summary of the book. The user have the name of the book that the user have passed, and we will send this user request to OpenAI API, which will internally use either GPT 3.5 or GPT-4 model to generate a summary of that book, and we will then display this summary in our book summary generator application. So this is how it works. Now we will see how ChatGPT is trained. We can divide this complete process into 3 different stages. So before we dive into that training process, so ChatGPT or OpenAI models have been trained on a huge amount of text data. This text data includes books, articles, blogs, and all of the text data. It's trained on a bunch of text data, which is all over the internet, including articles, blogs, newspapers. So it has been trained on a bunch of text data. Okay, so GPT 3.5 model has been trained with 175 billion parameters. And GPT-4 model, which is only available on premium subscription, is trained with 100 trillion parameters. So you can think of how much huge amount of data that it is trained on. So ChatGPT has been trained on a bunch of text data. In the stage number 1, generative pre-training is being performed. We will go in details of generating pre-training in the next part. So in the stage number 1, generative pre-training is being performed. After performing generative pre-training, we get the base GPT model as the output. In the stage number 2, supervised fine-tuning is performed. So after supervised fine-tuning, we get a fine-tuned ChatGPT model. And in the stage number 3, reinforcement learning through human feedback is being implemented. And after implementing reinforcement learning through human feedback, so reinforcement learning through human feedback improves the accuracy, and in the output, we get the ChatGPT model. So these are the 3 stages of that, how the training is being performed on the OpenAI or ChatGPT model. Okay, so let's go see the stage number 1, which is generative pre-training. So after collecting a huge amount of text data from all over the internet, which include articles, blogs, newspapers, and all the text data which is on the internet. So the GPT 3.5 model has been trained on the internet data till September 2021. So GPT 3.15 model will don't have the real-time information. It has the information till September 2021. So GPT 3.5 model has been trained on the internet data till September 2021. Okay. ChatGPT model architecture is based on transformers. So this all huge amount of text data is being passed to the transformer. Transformer includes encoder, decoder, and the transformers are being trained on this huge amount of text data. So we will be training the transformers on this huge amount of text data. And after training the transformers on this huge amount of text data, we get the base GPT model as the output. And the base GPT model, which we get in the output, can do language translation, text summarization, text completion, and sentimental analysis tasks. So the base GPT model can do these 4 types of tasks, which include language translation, text summarization, text completion, and sentiment analysis. But this is not what we aim for. Basically, in ChatGPT, the user writes a request and the ChatGPT will generate the response. Or the user passed an input query or user passed input request, and the ChatGPT model, which is a chatbot, will generate a response. So we want a conversation chatbot. We don't want to form the text tasks like language translation, text summarization, text completion, and sentimental analysis. These 4 tasks can be the part of our application, but these 4 tasks we don't want in the output, like only these 4 tasks can be performed, because we require a conversation chatbot. So after generating, after implementing stage number 1, generative pre-training, we get the base GPT model at the output, as we have trained the base GPT model on the huge amount of text data, and the base GPT model can perform these 4 tasks, but this is not what we require. So therefore, we just go towards the stage number 2. In the stage number 2, we perform supervised fine-tuning. In supervised fine-tuning, on one side, we have a human being, and on the other side, we also have a human being, but it is acting like a chatbot. So for example, on this side, human, for example, consider me at this side, and on the other side, we also have a human being on the right-hand side, but it is acting like a chatbot. So if I send a request like, hello, how are you? So if I just send this request, and then I will just get a response from this another human being, which is acting like a chatbot, I am fine. So as a human being, if I just send a request, hello, how are you? And the another human being over here, which is acting like a chatbot, will give the response, I am fine. Okay, so there will be this kind of real conversations. Like I will just send a request, and the human agent, which is acting like a chatbot, will give me the response. So here we have this kind of hundreds of conversations, and all these conversations will be saved. Okay, and all this kind of real conversations, which is happening over here, like please tell me about this topic, or please tell me about the book. So all this real kind of conversation will be converted into SFT training data corpus. Okay, so our SFT training data corpus will be in the form of request and response. So in our SFT training data corpus, our data will be in the form of request and response. Here, I will just send a request from here, and the human agent, which is acting like a chatbot, will give me a response of my request. So there will be a lot of requests and responses. Okay, and there can be for a single request, there can be multiple responses as well. Okay, so for a single response request, we can have multiple responses as well. And so this kind of training data corpus will be created, and there will be not 1 or 2 records, but there will be billions of records. Like for this conversation, where I will be sending the request, and the human agent, which is acting like a chatbot, will be giving me the response. So there will be kind of million of conversation record like this, the request and response. And for one request, we can have multiple responses as well. So once this kind of data set SFT training data corpus is being created, here we have the conversation record of millions of conversation, where I will be sending the request, and the human like chatbot will be generating the response. So when we have this kind of record of millions of conversations, so then we send this data to this complete SFT training data corpus to the base GPT model for training purpose. Then over there we will be using the optimizer as SJD, and in the output we get the SFT chat GPT model. So after we will be training our base GPT model on this SFT training data, and in the output we get the SFT chat GPT model. But there are some limitations of this SFT chat GPT model. So SFT ChatGPT model will give the output based on the data it is basically trained. If I ask some other question to this particular ChatGPT model that may not be there in that training data, it will give you a very awkward response, which you may not have seen elsewhere. So these are the limitations. So this is a limitation of this SFT ChatGPT model. And to overcome this limitation, we will be using reinforcement learning through human feedback in the stage number 3. So here is the stage number 3, reinforcement learning through human feedback. GPT 3.5 and GPT-4 models uses reinforcement learning through human feedback, and using reinforcement learning through human feedback, our accuracy improves. So here we have the human agent. Human agent sends a request, and SFT ChatGPT model, which we get over here, will give us the response. So here the human agent will send the request, and SFT ChatGPT model will give a response. We may have multiple different responses for a single question. Then in the next number step, as we have the response from the SFT ChatGPT model, and if we get multiple responses, like 4 different responses, the human agent will try to rank these responses. So SFT ChatGPT model has given us 4 different responses, and the human agent over here will try to rank all these responses to find out which is the best suitable response. And based on the ranking, based on this ranking, we can see over here the response B is the best response. So human agent will just rank all these responses which we get from the SFT ChatGPT model, and based on the ranking, we can see over here the response B is the best response. And based on this ranking, we will also create a reward model over here as well. So the researchers have created a reward model in which each response is being provided a score, which you can see over here, the score of response A, the score of response B, and the score of response C. So the researchers have created a reward model in which each response is provided a score, and the score is basically based on the probability, and so the score is based on the probability. And if the probability is high, that means the particular response is a very good response. So let's go ahead. So once we have the reward model, or once the reward model is created, then reinforcement learning is basically applied by a technique which is called as proximal policy optimization. Based on the proximal policy optimization, reward model update the rewards based on the response coming from the ChatGPT or OpenAI model. It will also make sure that it will update each specific reward using proximal policy optimization. Okay, so proximal policy optimization is a reinforcement learning technique which is used to improve the ChatGPT model or OpenAI model responses. So that's all from this tutorial. Thank you for watching it.